Welcome back to another episode of Tech Talk, where we dive deep into the fascinating world of technology, programming, and data processing. Today, we're exploring Unix tools and their enduring philosophy, particularly how they handle data processing tasks. We'll unravel the differences between traditional programming approaches and the Unix pipeline model, discussing why these concepts remain relevant in our modern tech landscape. So grab your headphones and let's get started. Let's begin with the basics of data processing in Unix. Picture this. You have a log file filled with URLs, and you want to analyze it to find out which ones are the most frequently accessed. In a typical programming approach, you might create a hash table to store each URL along with a counter to track how many times it appears. Each time you encounter a URL, you'd increment that counter, sort the hash table by those counter values, and then print out the top 5 entries. While this method is quite readable, it lacks the conciseness of the Unix pipeline method, which allows you to chain together a series of commands. For smaller datasets, both methods might work just fine. But the real advantage of the Unix approach shines when you're dealing with larger files. If your working set exceeds your available memory, Unix tools can efficiently utilize disk space. Commands like the sort utility are designed to handle datasets larger than memory by spilling data to disk. They can also automatically parallelize operations across multiple CPU cores, making them incredibly efficient for large-scale data processing. So, while a traditional programming approach might struggle with memory limitations, Unix tools can seamlessly scale up to handle massive datasets without breaking a sweat. Now, let's take a moment to appreciate the brilliance behind the Unix philosophy. Doug McElroy, the creator of Unix pipes, envisioned a system where programs could be connected like segments of a garden hose. This idea has led to a set of design principles that emphasize simplicity, modularity, and interoperability. A few key tenets of the Unix philosophy stand out. First, there's the principle of single responsibility. Each program should do one thing well. If a new job arises, it's often better to build a new program than to complicate existing ones with unnecessary features. Then we have interoperability, which means programs should be designed so their output can easily become the input for another program. This avoids clutter in output and eliminates the need for interactive input. Also important is rapid prototyping, which encourages building software quickly and iteratively, allowing for early testing and adjustments. Finally, there's the idea of tool utilization, favoring automation over manual tasks, even if it means creating new tools that may eventually be discarded. These principles resonate strongly with today's agile and DevOps movements, showing that the core ideas of Unix have truly stood the test of time. Next, let's delve into the concept of a uniform interface, crucial for the smooth operation of Unix tools. At its core, Unix treats everything as a file, whether it's a traditional file on your file system, a communication channel, or even a device driver. This uniformity allows for incredible flexibility in how different programs can interact with one another. For instance, when analyzing our log data, tools like awk, sort, and unique treat their input as a sequence of records separated by new lines. This standardization enables these tools to work together seamlessly, making it easy to process and analyze data in a pipeline. However, while this uniform interface is powerful, it does come with its quirks. Many Unix tools treat input as ASCII text, but the way they parse that text can vary widely. Some might use white space to separate fields, while others could rely on commas or pipes. This variability can lead to confusion, especially for newcomers. Despite these challenges, the interoperability of Unix tools is remarkable. You can easily pipe data from one tool to another, creating complex data processing workflows with minimal effort. This loose coupling allows for greater flexibility and makes it easier to compose small tools into larger systems. Let's also touch on the significance of standard input or STDN and standard output or STDOut in Unix. By default, STDN comes from your keyboard and STDOut goes to your screen. However, you can redirect these inputs and outputs to files or other processes, allowing for a high degree of customization in how data flows through your system. This design philosophy means that a program doesn't need to know where its data is coming from or where it's going. It simply reads from stdin and writes to stdout, enabling users to wire up inputs and outputs in whatever way they see fit. This loose coupling simplifies the process of building complex data processing systems. But what happens when a program needs multiple inputs or outputs? That can get tricky, as piping data into a network connection or handling multiple file paths can complicate things. However, the Unix philosophy encourages experimentation and iteration, allowing developers to find creative solutions to these challenges. Another notable characteristic of Unix tools is their treatment of input files as immutable. This means you can run commands repeatedly without worrying about damaging your original data. You can also inspect the output of each stage in a pipeline, which is incredibly useful for debugging. If you need to restart a process, you can write the output of one stage to a file and use that as input for the next stage, saving time and resources. In conclusion, the Unix philosophy and its tools have profoundly impacted how we approach data processing. By emphasizing simplicity, modularity, and interoperability, Unix has paved the way for powerful data analysis techniques that remain relevant today. Whether you're working with small datasets or tackling massive log files, the principles of Unix can help you build efficient and effective data processing solutions. So the next time you find yourself analyzing data or building a new tool, remember the power of the Unix philosophy. Embrace the simplicity of single-purpose programs, leverage the uniform interface, and don't hesitate to experiment. Thanks for tuning into this episode of Tech Talk. We hope you found it insightful and inspiring. Until next time, keep coding and exploring the world of technology.